Weather always feels personal, rain tapping on your window, sunlight warming your skin, or the wind howling outside your door. We experience it in the most intimate ways, shaping our moods and daily routines. But what we often forget is that these local moments are just tiny pieces of a much larger puzzle. Above us, the atmosphere stretches endlessly, a vast, borderless ocean of air that connects every corner of the planet. The sky we see is shared by billions, and what happens in one part of the world can ripple across continents. A single shift in the North Atlantic's weather can set off a chain reaction, triggering devastating floods in France, unleashing blizzards across Russia, and sending scorching heat waves rolling over the Caspian Sea. These events are not isolated, they are deeply connected by the invisible currents of our atmosphere. In November 2025, Europe and Western Asia witnessed a dramatic demonstration of this interconnectedness. Three extreme weather events unfolded almost simultaneously, all linked by a single dominant atmospheric pattern. While France struggled to cope with relentless floods, Moscow was plunged into an early and unexpected winter, with snow blanketing the city far ahead of schedule, while the Caspian region endured unseasonable, record-breaking heat, leaving communities sweltering under a relentless sun. These weren't random acts of nature, but the result of a powerful weather pattern locked in place, impacting millions of lives across three regions, the same sky but vastly different storms. As climate change accelerates, understanding these atmospheric links becomes more urgent than ever. Scientists and communities alike are racing to adapt, knowing that such disruptions are growing more intense and frequent. The story of this wild November is more than just a tale of three regions. It's a vivid reminder that we all live under one sky, and that the North Atlantic dipole can shape the fate of millions, no matter where they call home. At the heart of November's chaos was the North Atlantic dipole, a deep low-pressure system over the Atlantic and a stubborn high over Eastern Europe. This setup blocked storms from moving east, trapping them over Western Europe and channeling Arctic air south into Russia. The high-pressure ridge acted as a wall and a funnel, locking weather patterns in place for days. Moisture-laden air from the Atlantic fueled heavy rain, while the high's circulation stalled storms and opened a path for frigid air. The result: storms trapped in the west, Arctic outbreaks in the east, and a collision zone to the south. This wasn't just a blip, it was a semi-permanent engine driving extreme weather across the continent. The North Atlantic dipole shaped the month's most severe events. In Western and Central Europe, the dipole trapped Storm Claudia, a powerful Atlantic system over France and the UK. Instead of moving on, Claudia stalled, dumping relentless rain over already saturated ground. Rivers swelled, flood alerts escalated, and communities faced evacuation as water invaded homes and streets. The storm's stalled position also pulled in cold air from the north, turning rain to heavy wet snow in northern France, Belgium, and southern UK. Flooding gave way to a second crisis. Snow weighed down trees and power lines, causing outages and blocking roads. Emergency services were stretched thin, battling both water and snow disasters at once. Storm Claudia's 1-2 punch showed how a blocked pattern can compound hazards. One storm, two disasters, no reprieve. Days of rain from Claudia pushed Western Europe's rivers to the brink. Saturated soil meant every drop ran off, swelling rivers like the Seine and Loire at record speed. Flood warnings escalated, and towns that were safe days before faced sudden evacuations. The economic toll mounted, transport cut, farmland submerged, businesses shuttered. Meanwhile, the north saw rain turn abruptly to heavy wet snow, creating a slushy, dangerous mess. The weight of snow snapped trees and power lines, compounding the crisis. Emergency crews split resources between floods and snow, managing two disasters at once. The stalled storm divided the region into zones of crisis, stretching response teams to their limits. One weather event, multiple emergencies. Europe was left grappling with the aftermath. While Western Europe flooded, the same dipole funneled Arctic air straight into Western Russia. This wasn't a gentle start to winter, it was a full-scale Arctic outbreak, with temperatures plunging far below normal. Cities like Moscow and St. Petersburg saw autumn vanish overnight, replaced by a deep freeze. The frigid air collided with lingering moisture, triggering a classic high-impact snowstorm. Snow fell heavily and persistently, blanketing vast areas and promising major disruptions. Meteorologists warned this was no ordinary snowfall, but a storm that would bring the region to a standstill. Residents braced for blizzard conditions, dangerous wind chills, and travel chaos. The stage was set for a powerful, early winter driven by atmospheric forces far away. The Arctic outbreak slammed into Moscow with a ferocity rarely seen in recent years. As the polar vortex shifted, frigid air poured southward, and within hours, the city was transformed. Snow began to fall heavily, swirling through the streets and quickly piling up on every surface. Visibility dropped dramatically, making it nearly impossible to see more than a few meters ahead. Winds whipped through the city, howling between buildings and rattling windows. Highways became impassable as cars stalled and traffic ground to a halt. At the airports, flights were canceled en masse, leaving travelers stranded and runways buried under snowdrifts. Public transportation systems struggled to operate, and soon, buses and trams stopped running altogether. Schools and businesses shuttered their doors, and the usually bustling city fell eerily quiet as residents stayed indoors, waiting for the storm to pass. What made this storm truly remarkable was its persistence. For nearly 48 hours, snow continued to fall without pause, blanketing Moscow in layer after layer of white. The accumulation was staggering. Streets, parks, and rooftops disappeared beneath a thick, heavy blanket. Municipal services worked around the clock, but even snowplows and salt trucks struggled to keep up with the relentless onslaught. Emergency crews braved the elements to restore power to neighborhoods left in the dark by downed lines. The city's infrastructure was pushed to its limits, and the storm quickly became one of the most significant November snowfalls in recent memory. The sudden, overwhelming snow marked a decisive and dramatic end to autumn, erasing the last traces of fall in a matter of hours. But the polar vortex's displaced low brought more than just cold air. It unleashed a storm so powerful that even Moscow, a city famed for its resilience in winter, was caught off guard. Residents marveled at the speed with which the city was paralyzed, and many struggled to adapt to the sudden extreme conditions. The storm's speed and intensity served as a stark reminder. When large-scale atmospheric patterns shift, they can unleash winter's fury far from their origin, leaving even the most prepared cities at the mercy of nature's power. South of Russia, the Caspian region became the battleground for the Dipol's final act. In late November, the area saw a bizarre heatwave. Temperatures soared to record highs, feeling more like spring than autumn. The Caspian Sea, unusually warm, supercharged the air with moisture and energy. When the Arctic air finally plunged south, it collided violently with this warm, unstable air. The result: explosive thunderstorms, torrential rain, large hail, and hurricane-force winds. Cities basking in warmth were suddenly battered by severe storms within hours. The extreme temperature and moisture gradient turned the Caspian basin into a cauldron of atmospheric fury. This was the grand finale, a dramatic clash of cold and heat, all set in motion by the same continental pattern. The region experienced weather whiplash, a rare and dangerous event for late November. November's extreme weather wasn't just bad luck, it's a sign of a warming world. Across Europe and beyond, communities are facing storms and floods that seem to break records year after year. These aren't isolated incidents, but part of a growing pattern that scientists have been warning about for decades. The weather is getting wilder, and it's not by chance. Two main drivers are making events like these more severe: warmer oceans and a sluggish jet stream. As global temperatures rise, oceans absorb much of that heat, acting like giant batteries storing energy. This extra warmth doesn't just stay in the water, it powers up storms, making them stronger and more unpredictable. Record warm seas, like the North Atlantic and Caspian, fuel storms with extra moisture and energy, leading to heavier rain and more intense storms. When these supercharged storms make landfall, they can dump huge amounts of water in a short time, overwhelming rivers and drainage systems and leaving cities underwater. The jet stream, weakened by rapid Arctic warming, becomes wavier and more prone to stalling. This high-altitude river of air usually steers weather systems quickly across continents, but now it's slowing down and looping in unusual ways. This creates persistent blocking patterns, locking storms and cold snaps in place for days or weeks. Instead of moving on, weather systems get stuck, unleashing relentless rain, snow, or heat over the same areas. Storms that once passed quickly now linger, turning brief events into prolonged disasters. Streets stay flooded, homes remain threatened, and recovery becomes harder as each day of extreme weather adds to the toll. The result: more frequent floods, heat waves, and snowstorms that stretch emergency response to the limit. Hospitals, rescue teams, and local governments are pushed to their breaking points, struggling to keep up with the relentless pace of disasters. The slowing jet stream is turning weather events into weather sieges. People are forced to shelter for days, sometimes weeks, as storms refuse to move on, disrupting daily life and causing lasting damage. Climate change isn't just making weather more extreme, it's making it last longer. The new normal means not just stronger storms, but ones that overstay their welcome, testing our resilience and resources. The November 2025 events are a preview of what's to come. As the climate continues to warm, we can expect more of these drawn-out destructive weather events, unless we act to slow the changes driving them. November 2025's chaos is a lesson in how one pattern can unleash floods, blizzards, and storms across continents. The North Atlantic Dipole was the conductor, but climate change tuned the instruments to a more volatile pitch. These weren't random acts, they were predictable outcomes of a warmer, more energetic, and sluggish climate system. As the planet warms, such multifaceted disasters will become more common. We must adapt, better forecasts, coordinated emergency plans, and urgent action on climate change. The weather of November 2025 is a warning, a glimpse of our shared future under a changing sky. The air that brings rain to one region can bring disaster to another. The sky is speaking, and its message is clear. We can't afford to ignore these changes.